of each of these. Let's see, and I make sure I give them to people as they come.
Oh, 5 to each person?
No, yeah, I'm sorry. 1 to each person. 1 to each person. 1 to each.
5 total folks.
Well, 5 to you guys. This is your assignment. Work your way through. All right, I think other people are going to show up. RGB or exterior? We are first asking questions, answering questions regarding the lab, which is due tomorrow. My job is to get that back graded and get it back to you on Monday, because we are having a test on Tuesday, a week from today, here, dealing with sprayers, which I haven't gotten back to you yet, which I'm going to get back to you tomorrow, and soil sampling. Based on the last test, you'll probably be doing some calculations with sprayers, which we'll talk about tomorrow, how to calculate flow and pressure and get gallons per acre. So we'll cover that tomorrow. Any questions on the lab at this point? Spatial joints, Kriegang, IDW, all that good stuff. All right.
Fix everything.
Yeah, hopefully you guys are getting used to running through GIS. You're learning how to use it and becoming more comfortable with it, etc. And that's one of my intents in this class. And that in the lab coming up, you will become more involved in GIS. And the lab coming up deals with yield mapping, and that's what we're going to talk about today. Okay, so let's talk about yield mapping and moving into this. Yield mapping will not be on the test. First off, the handout, study questions. Everybody seem to work okay with these? And I'm going to pass this out. Back referring to capacitance type sensors. Jim, why don't you grab a copy of those two things right there? For moisture content, let's do Wednesday.
Oh, okay.
Great. Woohoo! Oh, you can give it to me now if you want to.
We'll
You can
go
do
a
it.
little bit.
Okay, you might take just take it. Moisture content is measured. Capacitance type. We're not going to talk too much about that. I used to, in this lab, talk a lot about moisture content of the grain, which is important. But we're not going to talk too much about that. Instantaneous yield monitors, measure, record crop yields on the go. We'll talk a lot about those. 3 types of data that appear on the line. Position, grain flow, time, a lot of times is on there, distance traveled, swath width, things like that. Number 4. A potentiometer can be used to measure the displacement of an impact plate that is struck by the flowing grain. I'm going to talk about that because in the old days they used a potentiometer. And they had a different type of impact plate that was used. Now it's a different type of setup, and we'll talk about that. Most combines built are equipped with sensors to measure actual cutting width of the header. False. There are some units that are out there. There are actually some units that are counting stalks that will determine the distance you are to a standing crop, that will determine your width of cut. But most of the units don't have that at this point. Types of yield monitoring that preceded the use of site-specific collect and weigh, batch type. So you harvest a certain area, you weigh all that stuff, determine the pounds, convert to bushels, know how many acres you covered, and that would be the classic, what's my yield in terms of bushels per acre. PC card is a device to transfer information. 3 methods of determining speed. Radar-based, we talked about that. Shaft speed, counting how fast either the wheels are rotating or how fast the wheel is actually rotating. Problem with that is you're not accounting for slip of the wheels. And so some people have a dummy wheel, maybe not a drive wheel, that's turning, that's maybe slipping or spinning with respect to the ground. And radar-based sensors. We talked a little bit about the Doppler principle and how that works. I'm going to go into a little bit more detail about that too. Header position switch controls the area counting and the measuring. So remember I said you pulled your header up if you're going fast through the field, put it down, and that's the header switch is usually to indicate that you're actually harvesting at that time. And I didn't like this last question. Describe the situation that might cause a farmer to need to calibrate his or her yield monitor more than once during a single harvest. They indicate possible crop moisture, changing environmental conditions. I don't know. Crop moisture, I guess, is the best way to go on that for recalibration. Okay, so those are pretty straightforward. A couple of differences, and I'm going to talk a little bit about speed, because speed is an important characteristic. Before we get into yield monitoring, etc. Because speed is important to determine your distance traveled. GPS, of course, can be used to measure speed, but the Doppler principle is one that's very commonly used as a laser-based or a sonar-based principle. And now, how does that system work? Well, you might not be able to do much here, so I don't have... markers. Uh-oh. You may have to go back and find some. All right. Let's improvise here. Smart. Okay, so here's our sensor that we're using, a radar-based sensor. And what I'm going to describe is if this is the sensor, and this is your crop or some sort of device over here. Okay. Now, if I send a sonar-based or a radio-type wave to this, what happens is the wave comes through at a certain frequency, hits this, and then it comes back at the same frequency. I'm trying to draw the same frequency. Okay, and it's picked up. And then if I send a frequency there and it comes back at the same frequency, the object is not moving. It's referred to as the Doppler principle. If the object is moving in this direction, and I send a radio wave to it like that, it's going to come back at a higher frequency. Because those waves are hitting sooner as it's coming towards me. And the faster this thing goes this way, the higher the frequency at which it comes through. That frequency from here to here is what's referred to as the phase shift. Now, if that object is moving farther away from me, that way, and it hits it with this wave, it'll still bounce back, but it'll be at a slower frequency. So by measuring the frequency at which it comes back, and looking and knowing the frequency at which it enters,